Hello, my name is Kevin Deisz, and today I'm here to talk to you about Prettier for Ruby. I work at Shopify. I'm based out of Boston, Massachusetts, and the question I'm here to answer today is, what is Prettier? So Prettier is a JavaScript package that provides a language-agnostic framework for building formatters. So what does that mean? It provides specifically a set of language-specific parsers, a parser for each language that it supports, and it provides a way to take that information from each language-specific parser and build a Prettier-specific intermediate representation. That means that it goes from language-specific to language-agnostic. It also provides a printer for taking that intermediate representation and printing out the formatted code. Finally, it provides a suite of editor tools and plugins that enable all kinds of better workflows like formatting on save, formatting on commit, and in general, just standardizing the format of your code base across all of your developers so that we eliminate the need for a lot of conversations like which specific linter rules to enable, when a lot of the time it's just handled by these kinds of formatters. So out of the box, Prettier started as a JavaScript printer, and so it came with support for all of the various JavaScript implementations and variants. Later on, it developed language support for HTML and all of those flavors, CSS, and Markdown. Now, these are the formats that ship with Prettier by default, but there's additionally a wide ecosystem of plugin support, and that includes Java, PHP, Postgres, Ruby, SVG, XML, Swift, and this is actually a subset. Some of these are community plugins. They live on other people's GitHubs. The official ones live within the Prettier organization on GitHub. Today, I'm here to talk to you about the Ruby plugin that I've been working on for about 2.5 years now, and it's both a Ruby gem, it's published to rubygems.org, and a node module, it's published to NPM. It's averaging about 20,000 downloads a week, and it's under constant development when I get weekends to work on it. So let's talk about the way that it works. Overall, what it is doing is formatting your source code. What this means is it's converting source Ruby code into a concrete syntax tree. You might hear abstract and concrete, the difference being that it has specific information about where the nodes were placed in the tree and specific information about the source. We then go and attach all of the comments to the tree that we found. These are, source code comments. We place them into the tree where we think they belong. We then walk that tree and convert it to a different kind of tree, which is the Prettier intermediate representation. We then hand it back to Prettier and say, go print this. Prettier has rules around how to print its own tree, and then it will go and get rid of go and print out the formatted result. So just to see it in action, this is poorly formatted or well formatted, depending on your perspective, Ruby code, which then passing through the Prettier package will give this output. So much more easily understandable and readable. So let's talk about what's happening here. The first step, as I mentioned, is converting the Ruby source into a concrete syntax tree. And what that means is we're going to spawn a process that runs Ruby. Remember, this is a JavaScript package, so we're spawning a Ruby process separately that's going to be acting as our parser. And we're going to run it through Ripper, a standard library package that will give us the syntax tree. We're going to add some extra information onto Ripper that Ripper doesn't itself track, but we're going to need to track some extra information, which, for instance, location information, excess commas, things like that. And we're going to specifically maintain the list of comments and their source location from the original source. So this is what the code looks like that spawns the process. You'll notice it disables gems. That's just for speed. You'll notice that we're passing the text that we're trying to pass over standard into our child process, which is our Ruby process. And eventually we return, at the end of this function, we parse out the standard out of the child process and return it as JSON. So what we're providing is this contract for this Ruby process is on the input, we are going to hand you Ruby code. On the output, we want a syntax tree in JSON format. It's worth it at this point to take a little side moment to talk about how Ripper works and how we're going to use Ripper to work. Specifically, you can require Ripper at any time as part of the standard library, and you define a class that inherits from Ripper. Once you have that class, you can define these on methods, on event, and these represent each node inside of the syntax tree. Now, each node is going to have this method called whenever it gets to a node that is like that in the source tree. And they have different numbers of arguments depending on the type of node, but a binary specifically will have a left and a right node and the operation that's being performed in between them. And for this example, we're just going to print out what we're getting just so you can see as an example what's happening. So we can create our own parser and call parse on it, and we get this result to standard out. We get 1 plus 2. So you can see how that kind of information gets built. But obviously this isn't enough information for us. We don't know where any of those nodes came from. So we want to provide much more information, much richer information back as part of our syntax tree back before we return it to Prettier. So we're going to loop over every single scanner event, which you can think of like literals or spaces or just tokens. And then each of our parser events, which are nodes in the actual tree, and we're going to define an explicit base method for each of those nodes. Then, when we want to track additional information or modify the tree in some way, we can just push more data into those base methods and then extract that into the syntax tree. What I mean by that is, for instance, there are a lot of nodes in the Ruby syntax tree that act like a linked list. They have one base node and then everything points to the next node. So you get a very wide tree. And what I mean by that is that things like words will have words new and then words add, words add, words add. So in this module, which is part of the parsing tree, or part of the parsing code, it actually changes the definition of those to instead just return a list. It just makes it easier to join with new lines or join with commas. Another time that we want to add additional information is when we have something like a multi-assign. Multi-assign can potentially have a comma at the end of the left side, which actually fundamentally changes the nature of the assignment and can change depending on splats and left and right numbers inside of the multi-assign. So we need to track that extra information. Finally, Ripper doesn't report comments back into the main tree by default, so we need to track those comments ourselves and keep track of the source position so that we know which nodes to attach them to. Finally, at the end, we're going to attach all those comments to the top level of our tree so that we can handle them in the next stage of processing. At the end of the parsing process, we're going to return JSON.fastGenerateResponse. We're going to return that JSON blob that we've generated over standard out so that our parser can then go and read it and hand it back to the node process. So the next step in the process is going to be attaching the comments to the concrete syntax tree. And so what we're going to do for each of these comments, we're going to walk through the tree and find the closest node to the source location for that comment. We're going to provide guidance to Prettier on which node to attach it to based on the preceding node before the comment, the following node after the comment, and the enclosing node, which is like the parent node. So you can think of this like if we had a comment on the 2 in 1 plus 2, and we had a binary node overall, the binary node would be the enclosing node. The preceding node would be the 2, and the comment would be after that. So we can provide guidance to Prettier. This is just a small simplified excerpt from our plugin information that we provide to Prettier for our printer. We say, okay, we don't want to attach comments to args nodes. And in order to get the child comment nodes, this is how we recurse down our tree, and this is how we print a comment. Remember that Prettier is language agnostic, so it doesn't have any concept of how to print a comment. In C, you would need 2 forward slashes there. In other languages, you would have other ways of delineating comments. In Ruby, of course, we have to have a pound sign. Finally, when we're providing Prettier with guidance, we can actually override specific behavior for how it finds the nodes it needs to attach to by reflecting on the nodes after they've been parsed and then determining where we want to attach that comment. And this can override the default behaviors, so we can provide very fine-tuned guidance for you can only put a comment on this node in this circumstance. All right, now that we've got a syntax tree and we've got the comments attached to them, the next step is going to be to convert that syntax tree into a Prettier specific syntax tree. And you can think of this like creating Prettier's language. Prettier has all of these fundamental concepts that they call doc builders, and those are just nodes in the syntax tree. And what we're going to be doing is building up those nodes to build up this tree that represents a language agnostic version of our source code. So the most important node in the tree is going to be the group node. The group node tells Prettier that this is a atom, this is a transaction of nodes, that if it were to hit the end of the line, then you can actually break it into two different kind of node, and you can make it so that it will print differently when it gets shorter. So in this way, we can handle long and short lines like that. Finally, we are going to provide line suffixes, which is to say, no matter what breaks in the group, no matter what changes, this comment is always going to be at the end of the line to make it so that we support comments appropriately. So that was all very abstract. Let's go through a specific example. This is taken from the Prettier plugin for Ruby source code, and it is the function that handles printing out op_assign. And what op_assign means is if you have like or equals, and equals, anything like that, operator assignment. So these nodes have three children. They have the variable that is being assigned to, we have the operator that is being performed, and we have the value that is being assigned. And what we're going to be doing is requiring from Prettier the document builders, the doc or the nodes in the abstract syntax tree. And in this case, we're requiring just four of them: concat, group, indent, and line. And you can see what we're going to be doing is first we're going to get the value out of the node. Then we're going to put the variable that's being assigned, a space, and the operator. Then we're going to have some special behavior. That line node inside of the Prettier tree, if it's on the same line and it all fits, that's going to become a space. But if it breaks, it's actually going to become a new line. And so we can use this behavior to our advantage, where if it breaks, it's going to indent everything one level, so in this case 2 spaces because of Ruby. And if it doesn't, then it's just going to end up being a space. Finally, we can group everything together so it knows that this is an atom that can be broken up and depending on the line length. And we'll return that function and register it in our list of nodes and how they get printed. And if we go to the command line and we run bin doc, which is a utility binary inside of the Prettier GitHub repository, it will show us the Prettier nodes that get generated, not the Ruby syntax tree, but the Prettier syntax tree, and how that gets generated. And you can see from here, this largely represents the exact code that we have called. The concat gets replaced with an array and so on, but the important thing to remember is the left side of this is language agnostic. Prettier has no concept of the fact that foo is a variable in this case. It just knows that foo is a string that it needs to get printed, and it has rules around how to go and print that. The final step is to take this tree, hand it to Prettier, and Prettier can go and print these out. And Prettier takes care of this for us. So this is one of the benefits of building within the Prettier ecosystem, is that we get to take advantage of all of the work that has been done on this for all of the other various languages that have already been built for this. So what we're going to do is walk the Prettier tree, and this is inside of the Prettier package. At each node, it's going to call the correct print function, which nodes can have different print functions. And then if you hit a line limit, then you're going to break the outermost group and shift it back. To give a concrete example of what this looks like, let's look at this small Ruby segment that has an overall op_assign node. And what it's doing is doubling the value of a list of items. Let's say that our line length was actually much shorter than 80 characters. It's whatever it is, and this is too long. What we're going to do is the outermost group of this tree is an op_assign node. So we're going to break the op_assign node as we saw earlier. and it's going to move that outer value in. Now let's say that this is actually still too long. The next outermost group that can be broken is the brace block associated with the map call. And so what we can do is we have provided rules inside of Prettier. Okay, this is too long, so we can go and convert it to a do end block. And so what Prettier will do is, as the maximum line length grows and shrinks depending on what it is you configure and how far in you're indenting, it can go and dynamically change how it's printing because it has this tree that it knows how to modify. So for the most part, as I've been creating this, a lot of this is kind of design decisions, really, of how you want to look at your Ruby code. And so for the most part, I've tried to stay consistent with RubyKaigi. I've tried to stay consistent with the overall community. I've tried to follow the rule that if it will always be idempotent, it will run on the same input, will always generate the same output. And finally, it should never fundamentally change the meaning of your program. Now, I probably should have an asterisk there because Ruby is incredibly flexible. And because of eval and metaprogramming, technically changing anything in your program could change the meaning of your program. So there's a happy line somewhere that we've tried to find in developing this. Just to go over, just to give a couple of examples of design decisions we've made here. The break, next, yield, and return keywords don't use parentheses. Super will sometimes get parentheses if you're overriding the arguments of the parent. There's no nested ternaries. We format numbers in very specific ways. We change between braces and do end for lambdas and multi-line. And just to give some more concrete examples, you can see it. We'll always favor aliasing with bare words. Array literals get transformed automatically in your source code, so if we can transform them. We will automatically convert things into using the shorter symbol 2proc syntax if we can. This is actually kind of interesting because technically that changes the arity of the block that's being passed in. So this became an option that you can optionally turn off if you're doing some pretty in-depth introspection here. Do end and brace blocks get converted if they can be, depending on operator precedence. Ternaries become automatic if you have simple if-elses. If you have anything complicated, it won't automatically do that transformation. Inline rescues become multi-line rescues, just to be a little more explicit. And strings. We're trying to be very careful with strings. If you have any escape sequences at all, we don't change the quotes. But if you have simple strings, we will go and change the quotes to be a little more consistent. We also, as you can see at the bottom of the slide, get rid of any kind of dirty interpolation and automatically use the pound and braces. In general, the philosophy from Prettier has been to minimize options. And really, the idea behind that is just because the more options you have, the more discussions you end up having. And oftentimes these lead to unnecessary bike shedding. So in the past, Prettier has added options to increase adoption of Prettier, which is no longer done because Prettier has already taken off and there's plenty of folks using it. When there's great demand from the community for an option, they have added those options. But that's kind of an interesting discussion because a lot of the philosophy stems from the idea that if Prettier existed when all these languages first came around, it wouldn't have been necessary to add these options because there wouldn't have been time for these communities to entrench in their ways of thinking about the right way to do something in a programming language. Because Prettier is coming in later, once these communities have already developed almost like dialects in a language, we have only added those options that truly reflect the trenches that people have fallen into. And finally, compatibility reasons with various formatters in other languages. Specific to the Ruby plugin, I provide these 6 options. They are meant to provide for the various dialects that I have seen in the community. If there is absolutely great demand for others, I will add them, but this seems to represent most of the trenches that people have fallen into. So now we get to what I feel like is kind of the most important part of this presentation. Because Prettier is embedded in an ecosystem, it's embedded in an ecosystem of other formatters. we get to take advantage of a lot of great stuff. And one of my favorite pieces of this entire thing is that you can embed parsers within other parsers. And what do I mean by that? As a concrete example, if you have a script tag within HTML, you want to both format the HTML code, but then also format the JavaScript within the script tag. So there aren't a ton of examples of this in the wild, but there are some times where it's just nice. For instance, you can embed Ruby code within other languages. If there's ever a time where you're executing Ruby code or showing Ruby code and you want it to be formatted, because Prettier can embed the Ruby parser into a larger parser, it can actually be formatted correctly. And I'll show you an example of this in just a second. Also, you can embed other languages within Ruby code itself, which can then be formatted appropriately. So for example, if we have a here doc and it says, and we know that it's using Markdown to format, and this is somewhat badly formatted Markdown, because Ruby is part of the Ruby plugin is part of this larger ecosystem of plugins, it actually knows that it has access to a Markdown formatter. And what it can do is detect that it's inside of a here doc with the correct prefix and pass it off to the Markdown formatter to get better formatting. And indeed, this is what it does today. Also, if we have embedded Ruby inside of something else, for example, like a Markdown file going back the other direction, we actually can have it go and format that appropriately. And one of the biggest benefits of having all of these things is that you can start to build other pieces onto this to really have tons of rich ecosystem of all of these plugins. And so in addition to shipping the Ruby parser and the Ruby formatter, the Prettier for Ruby plugin additionally ships with support for the Haml template language. And one of the nice things there is that Haml actually has a concept called filters. And filters allow you to put other languages inside of your Haml code. For instance, one of those being Ruby. And today, it will detect that you're using a Ruby filter and actually properly format your Ruby code within that filter. So this is all part of building within this ecosystem and taking advantage of all the work of all of the other developers as well who have done stuff outside of the Ruby ecosystem to build this great formatter for Ruby code. Going forward, I'm going to be working on lots of things. Number one would be speed. There have been a lot of interesting experiments in this. The one I want to show today is a Node native plugin that will actually, instead of spawning Ruby process, just return the Ruby objects directly into the Node process. Funny enough, this actually works great if you have enabled shared code within the Ruby installation, but not everyone has that when they've configured Ruby, so this might be a non-starter, but this is still an ongoing experiment. The other experiment that I'm looking at is replacing the Prettier printer for their nodes from the JavaScript side directly into a C library that we can call from Ruby. And this is just an excerpt from that code, and so that is an ongoing experiment as well. Finally, I'm trying to keep up with all of the latest and greatest Ruby syntax that it comes, specifically in 2.7. We now support pattern matching and all of the variants therein with array patterns and constants and hash patterns and all things like that. So that's exciting new features that I'm constantly working on to stay up to date with Ruby as it goes. So if you like this presentation or you're interested in better formatting your code, I hope you can get involved and check it out. It's on GitHub. We're constantly working on new issues and pull requests, and it's a good time. And finally, try it today. We have integrations into every single major formatter that we can find. So if you would like to try it, I'm sure it will work with your workflow. And yeah, thank you very much, and thanks for watching.